Namaste, everyone. A very warm good evening to all. So today we have a fifth session in the Paleo words, history, heritage, and um, horizons in that particular series, which we were organizing with the collaboration of Bangarama Sajjan College, BLD, Vijaypur. So today, Dr. Arati Deshpande-Mukherjee is going to talk on the platform of the history enthusiast, which is a privilege for all of us. So I take this opportunity to warmly welcome you, ma'am, to the platform of the history enthusiast, and thank you so much for accepting our invitation in your busy schedule. So, ma'am is going to talk on the title vertebrate fossil assemblies and their significance. That's an interesting topic, and yeah, many of them actually texted me to know about the title and personally got the link to join. Now I take this opportunity to also welcome honorary president of the history enthusiast, Srinandan Shastri ji, and founder president, Ms. Manali Momaya, and all the audience who are joining us through this session. Please stay active throughout the session. Now I request Ms. Manali Momaya to introduce our today's resource person, Dr. Arati Deshpande-Mukherjee. Over to you, Manali.
Thank you very much, Nidhi, for the warm welcome. And good evening to all of you who have joined us. Welcome back to the international webinar, Paleo World's History, Heritage and Horizons. So just a quick recap of what we did so far. We had embarked on a remarkable journey through paleontological thought. We began with Professor Jerry H. Lips, who revisited Darwin's idea of natural selection and paleontology. Professor Ashok Sahni then gave us a fascinating glimpse into the saga of Indian dinosaurs, dead but doing well, he said. And finally, on the day one, we concluded with Dr. Rajiv Nigam's lecture on foraminifera. Then we had Professor Vijay Sathe's talk on paleontology through the ages, Indian perspective. It was a historiographical narrative of the paleontological studies in India. And today we have the session that we were waiting for on invertebrate fossil assemblages and their significance. So it is now my great privilege to introduce our speaker for this session, Dr. Arati Deshpande-Mukherjee, Associate Professor in Zooarchaeology and in charge of the Archaeozoology Laboratory at the Department of Ancient Indian History, Culture and Archaeology, the Deccan College Postgraduate and Research Institute, Pune. Dr. Deshpande-Mukherjee's teaching and research interests span across archaeozoology, archaeomalacology, environmental archaeology, Harappan studies, ethnoarchaeology, and coastal archaeology. She is among the few practicing Indian archaeozoologists who specialize in protohistoric and historic faunal remains, with a focus on past human-animal interactions and the use of faunal remains as proxies for paleo-environmental reconstruction. Her collaborations extend across leading institutions, including the Archaeological Survey of India, state archaeology departments, and universities such as Calcutta, Baroda, Gadwal, and Nagpur. She has contributed to major excavations and studies at sites such as Bhirdana, Dholavira, Vadnagar, Kuntasi, Mahurjhari, Kurugudu, and Kiladi, to name just a few. She has also directed her own excavations at Somnath and in the Andamans. Dr. Deshpande-Mukherjee has been the recipient of several prestigious fellowships, including the ICHR Junior Fellowship, the Charles Wallace Visiting Fellowship to Cambridge, and the INSA INSA Visiting Scientist Fellowship at IIT Kharagpur. She has led major research projects funded by the UGC, ICHR, and SERB DST, including groundbreaking work on human responses to climate change in the Indus Valley Civilization. Her expertise has even brought her into the public eye as part of a Discovery Channel documentary on Vadnagar. Between 2021 and 24, she also served as controller of examinations at Deccan College. She is an active member of national and international academic bodies, including the ICAZ and the Society for South Asian Archaeology, the Society for Marine Archaeology, and ISPQS. With her vast experience in zooarchaeology, archaeomalacology, and Paleo-Environmental Studies. We are honored to with us today, have her with us today to speak on invertebrate fossil assemblages and their significance. So please join me once again in warmly welcoming Dr. Arati Deshpande-Mukherjee. Ma'am, the stage is yours.
Yes, so a very good afternoon to all of you. Before I begin my talk, I would really like to thank Professor Shastri, Manali, Nidhi for giving me this opportunity to talk on your platform. It was a really a welcome surprise to hear from Nidhi when she contacted me that she wanted me to give this talk in a subject of paleontology. I have been a student of geology and then I migrated to archaeology for my master's. So I have done a little bit of paleontology when in my much younger days. And so this was a very welcome topic and something which, because as Manali was telling you, that I have been mostly working in the Holocene on proto-historic cultures and historic cultures. So I had opportunity to work with late Professor G.L. Badam in his explorations in the Narmada Valley when he had given me his shell assemblages to study. So in that sense, yes, I had also contributed to some quaternary invertebrate fossil assemblages. But then my most focus has been on the later Holocene part. So thank you once again for inviting me, and it sort of makes you start thinking in a different line when you come across these topics which you have for some time not dealt with. Okay, so I will begin my talk. Only thing is, yeah, thank you, whoever is manning the this thing. So my topic is significance. It's a very simple topic: significance of invertebrate fossil assemblages and their significance. Now, people, scholars who are students of geology would find it extremely basic. And I was told that most of the students here would be of history and mainly social sciences, and maybe some professionals and some history enthusiasts. So, fossils, as we all know, and you must have heard through all these lectures before, these are the remains of animals who have sort of perished far, far back in time. And with time, they got deposited animals, different kinds of animals, like you have mammals, reptiles, fish, and so many other types. But in that, especially the ones which do not have a vertebral column. Now in nature we will find that there are animals of two types, two very broad groups, as we differentiate them as vertebrates and invertebrates. And vertebrates are what we are, under what we come, because we have an internal skeletal system. So we also have other animals like other mammals, fish, reptiles, aves, birds. All these animals possess a internal vertebral skeletal system, and it is around this that our soft body parts are put, and this gives us a framework to sort of move around and exist. But then there are other organisms who are also living organisms who are soft bodied, but they do not possess this internal skeletal system. Okay, but they have a skeletal system which might be on their external. So their soft body parts would be sort of enclosed within an external skeletal system. So something like shells. So you see these shells on the beaches. You find empty dead shells, but at some point of time they have the animals living inside. And same thing is with insects. Same thing is with say crustaceans like crabs. You have the soft animal is living inside a shell. Now these kind of animals are much more smaller in size compared to most of the vertebrate animals. And being smaller in size, their shell is also much more, what you can say, delicate as compared to the vertebral system which the bigger, larger vertebrate animals possess. For example, if you take a cow, or if you take a buffalo, or if you take a dog, or a cat or even human beings. We have a much stronger skeletal system as compared to these particular soft bodied animals who are much smaller in size, and nature has given them an outer shell as a means of protection. Now these kind of both vertebrate and invertebrate animals can be found on the earth everywhere. Even today also we have invertebrate animals. If you go into your garden, you come across snails which are walking around during the rainy season. You encounter, if you go to the Andaman Islands or you go to the coral reef areas, you see corals which are live. So these are invertebrate animals which are still living today. But then there are invertebrate animals which had existed in the past, and it is their fossils which have been discovered. And these have become very important in the sense that they cover a much longer time span. Even uh, if you compare them, say, with the findings of mammals, for example, like cattle, sheep, goat, or human beings, we have come on the earth much later, whereas some of these invertebrate organisms were on the earth very much far back in time, many more millions of years ago compared to the coming of mammals. Mammals come much later, or before that, the birds came. Before that, the reptiles were there. Like for example, the dinosaurs were there. So there has been, if you see the coming of introduction of these different animals in time and space has varied on the earth. So, in that sense, these invertebrate animals have been one of the oldest to be on the earth. And it is really fascinating that they got fossilized and they have been discovered now. And it is through this kind of evidences now we are made aware of these animals which had lived far back in time. So, if you see this fossil records which are there, a lot of fossil records have been found in different parts of the world. It's not only that they are restricted to certain areas, parts, like it's only not only in Europe, but we find them in even in Asia, we find them in Africa, we find them in India also. And many of these animals which are seen in the fossil record are seen even today. For example, as I said about molluscan shells, which you see on the beaches, you find their fossils occurring in the Himalayas or in some of the you know deposits which are found aligning many of the coastal areas, say in Europe and areas like that. So what we see is that invertebrate fossils definitely have a very long antiquity, which goes back, as you can say, as late as the Cambrian period. If this is a term which comes in, if you are familiar with the geological time scale, it goes very much back in time. So now these kind of fossils, where would you find them? So best place to find invertebrate fossils would be in sedimentary rocks. As if you all are not students, some of you might be, and who are not, there are different types of rocks on the earth. There are some which are very hard and which form because of volcanic eruptions a long time ago. For example, I'm based in Pune, and all around me is what we have is the basalt rocks, which are extremely hard. And then if you are in Karnataka part, you have stones like granite and things like that. But then there are certain rocks which have formed because of deposition of soil cover for a long period of time, and they have become sedimentary rocks. And it is in these sedimentary rocks that these are the best places for preservation of such fossils. Okay, and it is in these sedimentary rocks we not only see invertebrate fossils being deposited and being preserved, but we are also finding them even of our quaternary animals, which during the quaternary period in the last, say, 1 lakh years or 50-60,000 years ago, we had a lot of different kinds of animals here in the peninsular India. Like we had hippopotamus also, we had wild ancestors of our say cattle, buffalo. They have been also preserved in such kind of sedimentary rocks. So most commonly these are very soft rocks, you can say, and that is why their deposition became very easy. Now, in these, you find that molluscan fossils are very, very common. And what happens is that at some point of time, these animals, when they were living, uh, they must have died, and then they got deposited in these sediments. And with time, and this is not something which happened overnight, okay? This has happened over thousands of years, and because of the very good preservational conditions, they got buried in these soft sediments, and those sediments with time also hardened, and these animals remained buried within them. They remained very well deposited. And what happens is some kind of a exchange where the organic material, that is the softer body parts of the animal, get completely replaced by the minerals and other inorganic material which is from the surrounding sediments, goes into these animals, and that is how those fossils form. So another very good areas to look for such kind of fossils would be in coastal areas. Then you have beaches that have exposed cliffs or sedimentary rocks. We call such beaches when they have such exposed cliffs where you find such sedimentary rocks and having fossils. These are indicators of that at some point of time the shore was very close, and today you are finding these beach rocks fairly inside the on the land. That means at some point of time the shoreline was much different from what it was today. So this kind of features, we see such beach rocks if you go along the Saurashtra coast. You can see some of these beach rocks which tell us that um, far back in time, the the shoreline was much nearer, and it led to the development of such and to the deposition of such shells in such sediments which form such cliff areas. And with time, when the sea receded, the sea levels might have dropped, so these rocks came to be exposed. Then wherever ancient marine environments are there, which today are not there, one example I will give you is the Tethys Sea, which is ancient marine environment, a sea which was there, and it is where today our Himalayas are located. And it is the Himalayas also host a lot of these invertebrate fossils, because it is these creatures who are living in the water at that time, and because of tectonic activity, because of the kind of geological processes which were in action then, they got deposited after their death, and these led to the formation of their fossils. And then the Himalayas have been slowly been uplifted, these mountains have been uplifted, and that is how you come to see that. So whenever you go into the Himalayas in the Spiti Valley and many other places, you come across many kinds of fossils which are there, and these are remnants of a sea life which had existed very far back in time. Okay. So you have locations that were once under the sea, especially those with Cretaceous sediments or other marine deposits, are also known for their abundant mollusk fossils. So I can give you example. Again, we have if you look at the region of Kutch. So somewhere I think during the Jurassic times, it was underwater. Today, of course, it is a very hard, it's a landmass. And but during the Jurassic period, it was covered with water, and that is why we find so many invertebrate fossils have been recovered from this particular Kutch region. So yeah, so here I would like to um, tell you a little bit about this particular lady. She is Mary Anning, and her contribution to paleontology. We cannot really ignore it, because this lady was born somewhere in 1799 in a place called Lyme Regis, which is in In England, on the Dorset coast, and this particular coast of England is, covered with a lot of limestone hills, and it's a very beautiful coast. So it is also now known as a Jurassic coast because the hill surfaces which are there, or the sediments, they all belong to the Jurassic period, and these yielded a lot of fossils. Okay, and they are still yielding a lot of fossils today. I think it is even a World Heritage Site. So Mary Annings had a love and a passion for natural history, but at that time, I'm sure geology was not what it is today, and she was very much quite intrigued by the kind of fossils which she was finding staying in this particular place. So it was like a hobby for her to go and collect fossils, all kinds of fossils. She found fossils of some very extinct fish specimens, and some mammalian remains and things like that. But in that, she also came across a lot of ammonite fossils, and so she has her contribution is definitely very significant, because through her, she was not a trained paleontologist, but through her interest and the collections she made, it really helped other geologists, other paleontologists of that particular, because in those days, some of these disciplines were not so systematically being carried out as what they are today. There was a lot of discussions, sharing of information, because people were still trying to find out a lot of things. Today, with Google, we can just Google something and we can find so much information, but that was not there in those days. So if they found a particular fossils, people had to have real hot discussions over it and come up with a proper name for it and try to classify it, describe it. And this was what was the process. And same thing we see even happening later in archaeology also. So these kind of paleontological discussions were being conducted regularly in London. You have the London Natural History Museum, which houses a lot of fossil collections also. So it was Mary Anning and who really brought to light many of these fossils, and that is why she came to be called as, sort of a princess of paleontology, and her thing has always been referred to, taught to students. And recently there was a movie also which was made on her called Ammonite, um, where it shows her how she struggled in trying to collect fossils and to get recognition for them. So this is about Mary Anning and this particular place, which is became so famous for ammonites. And because, previously when people were finding fossils, they were still grappling with the idea of who these animals were, what do they represent, what are they actually. So it was her, through her work, she was able to carry out some identifications. So this is the famous Jurassic coast at Charmouth, where Annings made some of her very great finds, and you can see this all these cliffs which are there. House still contain a lot of fossils. People do still go fossil hunting in these areas, and so it is a very interesting work which was carried out by Mary Annings and later on carried out by the other paleontologists as well. Now, if you come to the invertebrate taxonomy, like any other vertebrate taxonomy, we also have been able to classify invertebrates because it's a very huge group of animals. It's not just a small group where there are just one or two members in that. So they come from very eight major groups. So we have one which is known as Porifera, which contains sponges. Sponges are very soft-bodied animals, and it is really interesting that how they also came to be preserved through time, because of their, soft bodied organisms will always have very less chances of good preservation. But in case of sponges also we see fossils. Then you have this area, which are all your corals, jellyfish, and sea anemones. So today also we see a lot of coral reef areas are there along the coast of along the Indian coast. If you go to the Tamil Nadu coast, if you go to the Gulf of Kutch, We have corals, we have a lot of coral reefs even in the Andaman Islands, and of course we have the Barrier Reef, which is there in Australia. But these are all living corals, okay? But there are also, you can find corals which are sort of preserved, which are fossilized on the surface, on the land surface, maybe not in a marine environment today, because the sea levels have dropped, but these fossils have been left preserved. So some kind of such preservation we can see even along the Dwarka coast. You can see them on the land close to the shore. Then you have the bryozoans, then you have the brachiopods. These are also quite fairly similar looking to mollusks. Some of these brachiopods are living even today. But a much bigger collection of fossils we have been able to see is from the mollusks, because you have these small bivalves, gastropods, cephalopods, and others, which uh, because of their hard shells, they tend to be quite well preserved, and these fossils have been recovered. For example, if you go to the Kutch region, you can see a lot of such fossils can be found. Then arthropods, which are related with your insect family, but of course we don't see fossils of cockroaches and this thing, but we do see certain interesting creatures like the trilobites, which today unfortunately are not there, but they were a very commonly found fossil representing from the Arthropoda family. Then, of course, you have the Echinodermata and the Graptolina. So, six of these groups are of marine organisms with a few freshwater exceptions, and that often have shells or hard structures that increases the odds that they will be fossilized. The other two mollusks and arthropods are found in marine, freshwater, and terrestrial environment, and that is why they always show very good preservation. Other groups of invertebrate animals exist, but the list, which are the ones who are listed above, they are very well, much better presented in the fossil record. Now, like all fossils, they have a whole process of how they form, how they come to be preserved, and of course, then later on, when paleontologists sort of recover them, those techniques are again different. So the formation of fossils is something very interesting, and it must be varying from place to place, because depending upon the sediments in which these animals had been buried. So the burial is always very important. There are a lot of factors which influence the preservation of fossils, formation of fossils. So the conditions have to be very conducive. If they are not, then fossilization will not take place. So the burial has to be very good. So just after the animal dies, the animal should be buried under some kind of a deposit. If they are sort of left to expose to Mother Nature, chances are that they will not be preserved. They will sort of deteriorate, and the whole animal could be lost. So burial conditions have to be very favorable. And in case of most of these animals, like in the case of mollusks, even if the animal within dies, the shell being very hard, and most of the molluscan shells are made up of calcium carbonate, which helps to preserve the shells very well, and that is why we see more of their fossils as compared to many of these other creatures. Their a tendency to become fossils becomes far less, depending upon the kind of shell in which they are housed. Compaction of sediments, the more compact the sediments, the better fossilization is going to take place. Because if it is very loose, the chances are that the animal might get displaced, it might get completely deteriorated, destroyed, and you need many years of deposition history. For example, you need that it should be at least over 1 million years for the sediments to build up over these animals which are sort of buried. And not only with the layers of sediments building up, there has to be some kind of replacement of those inner soft body parts by the surrounding sediments. There is inorganic material in those sediments that should be able to go inside the bodies of these soft animals and sort of replace the soft body parts with the hard body parts, and then that is how it could lead to fossilization. So something like mineralization, you know, that inorganic material gets deposited. And it's very interesting that in many of them you see the formation of crystals. In some of the fossils, when they are opened, you see formation of crystals. For example, you also see the formation of opals. In Australia, you have fossils when the rocks are sort of split open and you have a fossil, it might be completely sort of opalized. You know, opals are sort of precious gems, but some of these fossils also become sort of opalized. So minerals in the surrounding water, they seep into the shells and the surrounding sediments, hardening them into a rock and preserving the shells as fossils. So whether the sedimentation is taking place on land or in water, the minerals should be able to do this kind of a replacement of the soft body parts. Then only it could lead to the formation of a good fossil. So here you have some of these fossil corals, which we see even if you go, say, to places like Dwarka and all, you can see some of these fossil corals are at least 2-3 kilometers inside. You will be able to see them. These are indicators of that the coastline was very much there, and these the corals were in a living condition at that time. And when the sort of sea receded because of sea level changes, these animals got exposed, and they are animals which live in a marine environment. They need in an aquatic environment. They cannot live on dry land. So once they are sort of exposed to nature, to hot climates, sun, and things like that, these might have perished. But at the same time, fossilization led to the formation of such fossil corals. So there are many different types of fossil corals of depending upon the coral families. You know, in corals also we have very very different types. So again, their fossil forms are also very different. In my talk, the whole subject is extremely. It is a very interesting subject, and it is a very vast subject. So, to sort of condense it for this particular lecture, I've just selected a few examples of the different types of invertebrate fossils which we commonly encounter in today. So, I'll be mostly speaking about them. I may have missed out some, so please excuse me for that, because I have to take consideration of the time also. Another very commonly found fossil are these brachiopods. They look a little bit like molluscan shells, the bivalve shells, but these are again having their own phylum belonging to Brachiopoda. They also have a very long history of life on Earth. They are at least 550 million years ago they had appeared, and they are again can be dated back to the Cambrian age fossils. But we also see some of their descendants living in some of the oceans and seas. They were very abundant during the Paleozoic times, and often the most common fossils in rocks of that particular age. So you will find that certain in this geological time scale, there will be certain fossils which will be found only in those particular time periods, and after that they have sort of become extinct. And so they are in a way some kind of index markers, and so these have helped geologists to sort of date their deposits, so some kind of a relative dating using fossils. So they also vary considerably in size. They are aptly named Carboniferous genus, this Gigantoproductus. It may grow up to 36 centimeters across. Then you have some very, very tiny ones, which might be just 2 centimeters, just as large as a pinhead. They are also particularly suitable for paleoecological studies because, their growth, their habitats are controlled by water depth. They require, see, invertebrates, especially like your corals, uh, mollusks, to a certain echinoderms. These particular animals are very very habitat specific. Okay, unlike your mammals, which may occupy a very very vast region, these are much more restricted. And once they are taken out of their environment or habitat, they can perish because they may not be able to sustain the changes which they have to do. So we find that, things like water depth, salinity, the kind of oxygen levels which they require will change from animal to animal. Within even mollusks also, we see that there are certain kind of molluscan species which live only on land. Then there are certain ones which only live in fresh water. There are certain ones which live only in brackish water, in estuarine areas close to mangroves, and then there are some who live only in the sea. Now, either of them, you shift them to, if you try to make a mollusk which is living on land, to make it try and grow it in a marine environment, it is not going to grow. Okay, so they are very habitat specific, and because of this thing, they are very, very good environmental indicators. And now in archaeology, we are using a lot of such kind of archaeomorphological remains to reconstruct paleo environment, paleo climate, and so forth. So these can tell you about shifting shorelines, how the past distribution of land and sea was. Now, due to the rapid evolution of some brachiopod lineages, they can be useful for understanding the relative ages of rock succession and for correlations. So you can also use them for finding out ages of certain rocks, because if when you know that brachiopods were living, say, during the Cambrian period only, and in the later periods you don't find them. So if you are getting some rocks with brachiopods in it, you can with guarantee say that yes, this belonged to the Cambrian period or to the Permian period, or these are geological time periods it might have. Then there's another group which is the trilobites, another very interesting fossils. And they are again very extinct marine arthropods. Arthropods are nothing but, our all present day insects come under this arthropod group. So they also appeared somewhere around 21 million years ago, shortly after the beginning of the Cambrian period, and lived mostly through the Paleozoic era for nearly 300 million years. Okay, and when they were dominated by the seas. So these particular trilobites, they are have a very characteristic form, which is a three segmented form, and their fossils are found mostly in Europe. If you go to England, you find a lot of these trilobite fossils. So this is from the arthropod family, that these are the one of the most interesting fossils which are most commonly found. So it is not necessary that all the creatures in the past got fossilized. Um, Depending upon their body parts, depending upon the kind of fossilization agents which were available for them, only those animals could get fossilized. So things like trilobites, corals, or ammonites, these are the more commonly fossilized animals which we invertebrates which we see. Now, coming to this very beautiful fossil, these are the ammonites, and they are also extinct. You can say belonging to the phylum Mollusca, and if you have seen shells of the Nautilus, they look very close to that. And ammonites again were living, say, in the ancient stage of the early Devonian stage, and many of them sort of vanished after the, say, the Cretaceous period. So in the Cretaceous period especially, they were extremely commonly found, and again they were living in the sea, and with time these got deposited as fossils. So they also make very excellent index fossils, and they are being frequently used to link rock layers in which a particular species or genus is found, because there are different kinds of ammonites which are there. Their fossil shells usually take the form of planospirals, like, they are this thing. If you have seen some of the gastropod shells, there it is just one shell which goes into a torsion. But if you see the ones which are with the bivalve, the shimpli, or there are two valves which are hinged together. So these are sort of one valve specimens. And and again, their size ranges are very, very vast. Okay, I have seen some very huge ones, quite quite big ones in my geology department at Ferguson College. And if anybody is interested in this thing, they can also visit. I don't know of any other place in India where you might be able to see them. Of course, the Indian Museum in Kolkata has got a very good collection of invertebrate fossils. But in India, we find that the Trichinapalli area of Tamil Nadu today it is on land, right? But in the past, there was a very big sea which was in existence there, and it is in these that these ammonites used to live, and that is why a lot of ammonite fossils have been found in the, as they call it, as the Trichinapalli Cretaceous deposits of this time period. So they are really very fascinating. So it is because of this, spiral shape, they got this term ammonite, and they were also sort of supposed to be resembling the coiled horns of the ram, that is the male goats. If you have seen the rams, the male goats are much larger in size. Their things are horns are very very much coiled. So it was Pliny the Elder who called these fossils as Anemones cornua, because the Egyptian god Ammon was typically wearing these ram's horns. The name of an ammonite genus ends in "ceres", which is from the Greek word meaning horn. So they are supposed to be resembling the horns. And it is very interesting that the Greek philosophers, during the Greek civilization, they were one of the earliest, I think, people who were intrigued by fossils. And they had already started collecting fossils, and they were bringing them back to their, maybe settlements, and discussing about them and philosophizing about them. So some of the earliest collectors, they were collecting them actually as curios. Okay, uh, these invertebrate fossils. In India, we have our own shaligram, which is nothing but an ammonite. And so shaligram, many of you must have seen that it is kept in our puja ghar. You find them in temples, and it is a non-anthropomorphic stone, specifically a fossilized ammonite, which is found in the Kali Gandaki river in Nepal. So in this particular river in Nepal, you get these pebbles. They're cobbles and pebbles. They're literally pebbles of different sizes. Okay, and the people collect them, and if you break them, it's not necessary that all of them might contain, but if you break this particular pebble, you will get the ammonite fossil inside. you know so these have been sort of scored down from the Himalayas, and because of so many things. There might be because of rains, because of tectonic activity, and so the rivers are all the time scoring the Himalayas and bringing down lots of rocks and things like that with them. So what they are doing is that they are removing these pebbles which have got these fossils inside. And this fossilization must have happened when the Tethys Sea was there, and then it got replaced by these Himalayas which started coming up, and these fossils got sort of remained there. And now with time and the natural forces are bringing down these stones regularly into the river valleys, where the people can go, and if you break these rocks, you will get these ammonite fossils. And so that is why they are considered to be in Hinduism, they are considered to be very holy. They're supposed to be a manifestation of Lord Vishnu, because it looks like a chakra. So something to do with creation and things like that. So people tend to keep these in their houses, tend to worship them. If you visit Nepal, you can buy these on in the streets. And even places like many of our tourist place, religious places, if you go to say Banaras, or if you go to Rameshwaram, they will be offering you these kind of shaligram. But I think now many of them probably these are made fake. They may not be the actual fossils what we are seeing, but these might be sort of man-made. Okay, so one has to see them very carefully to identify whether they are actually natural ones or they are fake. Because these days a lot of fake things are also coming into the market. You have Now we are making diamonds in the lab. We are also making a lot of gemstones are being made in the lab. So you can also make these kind of replicas of fossils just for selling purposes. So if you split these rocks, you get these kind of um, fossil inside, which is nothing but a ammonite. So it is being regularly used in rituals to bring in prosperity, protection from negative influence, and everything good can happen to you if you have this particular shaligram in your collection. So these are some ways in which we have been using these invertebrate fossils in our daily lives. Okay, because we don't use all the other fossils, but this is one fossil which has been very commonly used. Now we have the fossil mollusks, which you can say that mollusks compared to these other animals, like even take humans. Humans come much later in the geological time scale. Before that, we had some of the early mammals which came. Before that, we had the birds. Before that, we had the reptiles. So mollusks have a much longer, antiquity on the earth. One of the earliest to come, and at that time, the earth was, I think, most of it was covered with water, and that is why these mollusks thrived. And with time, they many of them slowly shifted to the land and becoming terrestrial mollusk. And that is when other animals also started coming onto the land. So your reptiles also took to the land. So when the mollusks were in the very early time periods of the geological time scale, it must have been a very watery world in which these mollusks were living. And once their habitats were completely replaced by, say, terrestrial habitats, these got fossilized and they have sort of remained behind as fossils. Then we have these other ones like belemnites. So belemnites are also very interesting looking ones, sort of very long cones, which also have been very commonly found at many places. Now, what is the significance? As my lecture was supposed to be, that why are these fossils significant? Like terrestrial of terrestrial mammals, the quaternary animal fossils which we have, they tell us a lot about the life of the animals during the particularly the quaternary period in the last, say, 60,000 years or 70,000 years, 80,000 years. That how was the landscape? Was it a very wet landscape? Was the environment very congenial, or was there aridity, drought, and things like that? So a lot of things can be learned from those kind of vertebrate fossils. But similarly, even significant are invertebrate fossils. Firstly, they have been used a lot in trying to reconstruct stratigraphy and biostratigraphy. They have come to be labeled as index fossils because at certain time periods in the geological time scale, you find, like, for example, the trilobites. They were in a certain period, and after that, they have sort of become extinct. So when you get particular rocks of that time period containing those fossils, you can say with assurance that they belong to a particular time scale. Even with mollusks, also certain mollusks or brachiopods, they came at a certain time of the geological time period, and then they vanished from the earth. So this helps us in doing some kind of a relative dating. Then we can also understand the evolutionary history because they have such a long fossil record, and uh, many of these are even living today. For example, the mollusks or corals, you still find them living today. So they have a very long evolutionary history. And it is very important to know that how they have evolved through the centuries, through the millions of years, because of their, what do you say, what was it that made them live so long? This is some question. I mean, we are all the time trying to find out, and this is part of science. That it is, you need to be curious. You need to be trying to see that how different creatures have evolved on this earth and how they continue to live, and how we are going to even live in the next, say, 10,000 years or so. So, such animals are of interest to people, especially evolutionary biologists, when they're trying to reconstruct their evolutionary history. And then this also tells us about the history of the earth, that how long ago did the earth form? You know, because if you have such ancient creatures who are nearly millions of years ago, that means Earth's history is even much older than that. Okay, then you have paleo-environmental reconstruction, because it is not that we try to reconstruct paleo-environment only for the last 10,000 years, when humans started moving around and started doing, making their civilizations and things like that. But we have to also be concerned with how paleo-environment was, say, 1 million years ago or 2 million years ago, because this past history is definitely of relevance to us even today, because we should be aware that there were some kind of climatic changes or some kind of paleo environmental changes which brought about many disturbances on the earth, which made many animals become extinct. For example, take the history of the dinosaurs, you know, that after the Cretaceous period suddenly the dinosaurs disappear. What was it that must have changed that led to their extinction? So there are many such animals which have become extinction, and one needs to find out that how did they become extinction. Was it because of changes in the paleo environment? And of course, paleo environment has been an important factor in deciding the thing of these animals. If their environment was conducive for them to grow, these animals thrived, and once it was not, many of them perished. So we can do a lot of environmental reconstruction. We can see, you know, what was have been the water depth, what might have been the substrate type, and even the salinity conditions, how they must have been at that particular time for certain animals to live. Climatic changes. The climate has also played an important is playing an important role for us even today. But for paleoclimatic studies from the past, and for studying something of 1 million years or even older to that, these invertebrate fossils are giving us a lot of insights about how, because depending upon the kind of conditions they require would immediately tell you about how the environment was or how the climate was at that particular time. Was it a very wet environment? Was there a lot of rainfall, or was it very dry arid conditions that made these animals to thrive, or they completely died out? Reconstruction of past ecosystems, you know, faunal assemblages and the structures of fossil communities reveal information about interactions between organisms, the structure of food chain, and the overall health and dynamics of ancient ecosystems. So we know that we have various different kinds of ecosystems today in which different kinds of animals are living today. Even our humans also, we have been able to adapt to different types of ecosystems. But in the case of certain animals, it is not so. They, as I said, they have very restricted habitats. So if they are removed from their habitats, it's quite likely that they may perish, and they may even lead to their extinction. So looking at how a particular ecosystem was in a particular area by studying this fossil will give us a lot of insight into how it was in the past. And windows into extinct life. Now, as I said, that some of these creatures are still living today, like corals, mollusks. We do find them in the waters around us, and they have their ancestors who were there in the past. But there are certain animals and invertebrate animals which have sort of become extinct, and these are also very interesting. So such animals, to learn about what was there in the past, is also very relevant. Just as today we learn about a lot of pleistocene animals which have become extinct today, say Bos nomadicus, or some of the horse animals, or some of the hippos, you know, in the quaternary period we had hippos in India. Today we don't have them, they are only in Africa. So this kind of extinct animals which were there, you can get insights by studying such invertebrate fossils. Then you have it has definitely invertebrate studying invertebrate fossils has made a big contribution to the study of paleontology, because paleontology is not only confined to studying about vertebrate animals, but also invertebrate animals. They are also a very big part of this particular discipline, and how their preservation has happened, what are their different types, their classification. So, invertebrate fossils, in a way, have helped to further, expand this particular discipline of paleontology. And it also goes into becoming micropaleontology, when there are even more smaller organisms which we cannot really see with the naked eye, but you can see them under microscopes, which have also got fossilized and which come under micropaleontology. But here I will not be speaking about that. So, with this, I would like to finish this lecture. I have tried to simplify it as much as possible, because this is a very, very vast subject. One could just for a day just keep talking about brachiopods, or one could be just speaking about ammonites. And to end my lecture here, I have put some, as I said, significance of fossils. Today humans are trying to use everything what is there in their natural resources. So people are also making jewelry out of. So these are ammonite earrings and ammonite pendants, which are being sold as jewelry. So you can see that how much significance we have of invertebrate fossil assemblages, and you can definitely get a lot of information. Thank you.
Thank you very much, ma'am. It was indeed a very interesting lecture, and as an introduction to invertebrate fossil assemblages, it was indeed very valuable to all our audience members, because we are all students of history, and we have some touch with archaeology, but paleontology is fairly new to us. And because these are very important part of our ecosystem, and they have been uh, a long time ago and still continue to be, I think this was a very important topic, and you have absolutely given us a lot of knowledge about it. So thank you very much, ma'am. With your permission, there are a few questions, if we could take those up.
Okay.
Yes, ma'am. So here is the first question. It's by Nandan sir. Very recently, the journal Paleosciences is brought out by Birbal Sahani Institute of Paleosciences, Lucknow. Is there any other journal from India exclusively on paleontology or paleosciences?
Um, I'm not so aware, sir, because I think the geology journals, your geological, which is Geological Survey of India, must be having some journals. But other than that, just for paleontology, I'm really not sure, because this has not, I mean, in recent years, I've not been doing any paleontology at all. So I'm not referring also to many of them.
Thank you, ma'am. So this is my question. As a student of archaeology, I'm more drawn towards the proto-historic and historic parts, and so that is where my question is. You worked on Harappan and proto-historic sites. So have you? How have invertebrate assemblages, especially shell remains, contributed to our understanding of Harappan trade, craft, and subsistence?
Yes, definitely. I mean, and that is what I've been working for the last 20 years, documenting all kinds of molluscan shell remains from Harappan sites like Dholavira, then you have Kuntasi, Shikarpur, Bagasra, and coming up. So yes, the Harappans also loved mollusks, and they were using it as a raw material in their shell working industries. They were very fond of shell. It was not only just meant for decoration or just to look good, but I think it was something like a a symbol which they were identifying themselves with. So that is why the shell bangle becomes a very, very commonly found object in the Indus Valley civilization. It is worn by both men and women. The women are being buried with those shell bangles. So, not just adornment, but also something much bigger than that. They had some kind of a socio religious significance attached to it. Besides bangles, they were also using a lot of beads. They were also using certain kind of bowls which were made from a certain other shells called ladles, you know. And recently I had a paper in one conference proceedings from Barcelona where I studied the shell ladles from Dholavira. Now these shell ladles have always been a very what do you say, people have not been able to actually find out their purpose. And they are really enigmatic in that sense, because we never find them in any kind of burials. We have found them in the workshops and things like that, and you don't see any kind of soot marks on them, so people used to think that they might have been used as lamps and things like that. But or were they holding something? But that is also not very clear. And what was their actual function still remains a mystery. And these are very, very nicely crafted. They are not so common as what we see about the bangles. So the Harappans were using a lot of shell in their domestic use, for their adornment, for their religious purposes also. And many of these objects which were being manufactured in the Indus Valley, they were going as far as Mesopotamia, you know, where they were also using some of these shell objects. Because we do see shell bangles, shell ladles have been found at sites in Mesopotamia. We see them in sites in Iran also. The famous site of Shahre Sokta, third millennium site. There also we are seeing Harappan made shell bangles and beads. So yes, for the Harappans. And there's a whole connection which Harappans had with their shell, and it goes right up till, you can say, the seventh millennium site of Mehergarh, the Neolithic period. That is when we see one of the earliest evidences for the use of, say, shell bangles, shell beads, coming at this as early as the seventh millennium at Mehergarh, the Neolithic period. So yes, it was very much in thing, and that too exploiting marine shells there, and specific marine shells. Not every shell they were using. It was, they were targeting only specific species.
Thank you so much, ma'am.
Yeah.
Nidhi.
Ma'am, I have a question. Uh, how can one recognize an authentic saligram, and what are the distinct features that determine the originality of a true saligram? Because, as you told, many vendors are
Fakes are
selling
also.
fake saligrams, so that's why.
See, for me also, it is a little bit difficult, but you know, you can make out the stone. What you could do is, maybe on the stone you put some little acid and see if it's sort of effervescence. That means it is some kind of calcium carbonate, something is there. But if it is some other material, like if it is some kind of made from some resin or something, you know, plastic material or artificial material, the whole thing will be different. And even the contours inside of the fossil also may not be so completely regular. In a natural fossil they would be a little bit slightly irregular, because that is how it is formed. So one has to probably use your thing to sort of even out. And the texture of the that particular stone, how heavy is it, how light it is, one has to look into all that to separate out whether it's a natural one or an artificial one.
Thank you, ma'am. Thank you so much.
Thank you so much, ma'am. There is another question by Nandan sir. Pelecypods are aquatic mollusks. Where are they found in India?
Yeah, so pelecypods are nothing but your bivalves. The shimpli is what we refer to, and these are found in aquatic, both freshwater as well as marine estuarine ecosystems. You do not find them on land, because they're made up of two valves, and they cannot live on land because of their nature of their body. So you find them in freshwater rivers, streams. You go to any river stream in India, you will find these pelecypods. There are different varieties in that. There are like lamellidans, Parisia, so many things are there. And depending upon the kind of families and species, genus, so it varies from the ones from peninsular India to northern India to eastern India. But they're very, very commonly found in all our water bodies. The ones which are living in, say, your marine habitats, again you have a large number of families in that as well. But those ones, compared to the ones which are living in freshwater streams and rivers, are far decorative, much more beautiful to look at, more attractive in different colors with different designs, as compared to ones which are in on found in our rivers and lakes. They are much more very simple, very dull looking. They have an outside, if you see, they have a coating which is their protective coating. So the they are found in both these kind of habitats, whether it is freshwater or a marine habitat.
Thank you so much, ma'am. I have another question. Actually, I have a bunch of questions, but as much as the time permits. This is another question based on archaeology again. As an archaeozoologist and archaeomalacologist, how do you differentiate between an invertebrate fossil and a modern shell or bone when found during an archaeological excavation? Because this has always
Yeah.
fascinated me.
So as we have been talking, see, fossils are they are remnants of that particular animal which had existed thousands of years ago, millions of years ago. Okay, so what has happened is that it has got converted into like a stone. huh? This is in very simple languages. But whatever its soft body parts where they were, they have been replaced from minerals outside. Okay, which have made those parts hard, and it has made like an impression. Okay, so that fossil is always much more heavier. If you break a fossil, you will see a lot of minerals inside, you know but that is not true with our archaeozoological specimens, because our archaeozoological specimens are not very old. Okay, they are not we are generally limiting it to 10,000 years ago, that is just beginning of the Holocene. And our archaeological specimens, because of such a short time span, they have not been able to get fossilized. Now if supposing if the bone lies there buried for another million years, then it might turn into a fossil. But as of now, they have not become fossilized. That kind of replacement has not happened. Okay, the bone might have become hardened because of the outside, some of the sediments acting upon it and this thing, but complete replacement doesn't take place. It has not become a rock or a stone. So that is how we distinguish. And in fact, even our students also, first thing I tell them that in an archaeology lab, what specimens you are seeing, these are not fossils. The fossils, if you want to see, you have to go to the paleontology lab, because in the archaeology uh, time scale, fossilization could not take place because of a very short time scale of just 10,000 years, in which the animal must have died, got buried, and then it remained there. But by the time it is leading to some kind of fossilization, we have already excavated it and taken it out. So it is not a fossil. So basically, the composition of the bone also will tell you that you can distinguish whether it is a fossil. Fossils are heavier, hard material. They will have a crystalline structure inside, a minerals inside. They're made up of different minerals. And whereas in the archaeological bones, the bony, you will still get some organic material left inside the bones. They are still preserved, which you will not see in the fossil ones. Sometimes archaeological bones also, because of maybe some kind of the kind of surrounding sediments in which they are lying buried, they may get some kind of crystalline these things over themselves. They might also get a little bit of fossilization on the outside, but they have not become yet fossils. So that process for it to become a fossil, they could not achieve. That's why they remained as archaeological specimens. The much younger material, and most of our historic sites, the bones you are seeing are all not fossilized. Okay.
Thank you so much, ma'am. Thank you. And this is another question from me again. In the presentation, you mentioned that ammonoids are excellent index fossils. So I want to ask you to elaborate a little bit more on how they are so useful in dating and correlating rock layers.
Uh, what I will tell you is that, as I said, that they are found in particular uh, deposits which are of a particular time period. Okay, they are not found in the later thing. For example, of the Cretaceous period, you do not find them in the later time periods, or they may not be found even in the much earlier time periods. So they become like an index fossil for the Cretaceous deposits. So any such kind of deposits where you are getting these kind of ammonite fossils will be able to help you mark them as a Cretaceous deposit. This is the most simplistic way of geologists will be using other ways also of finding. Now they have got dating methods and things like that. They must be using that also. But yeah, fossils were one of the earliest to be used for dating in geology for a very long time, till many of these methods came into being. So that was a very easy way of, for example, they have given so many time periods within the geological time scale, and many of these fossils in the ammonite types or mollusk types also, they are very, very, what do you say, pinpointing to that particular time period. Okay, you will not find it in the preceding time period or in the succeeding time period. So they become like an index fossil.
Thank you very much, ma'am. And one last question, which I have not posted. But do we also find invertebrate fossils in resins? Resin.
Yeah, you mean to say something like amber,
Yes, amber.
like what
Yes,
we
sorry.
say in Jurassic Park, no?
Yes, ma'am.
Now, for example, the amber which was shown in the Jurassic Park movie, yeah, you have ambers which have been keeping preserving insects. So in a way, those are also invertebrates, and they are also sort of fossilized. So such kind of fossil things will be there in such deposits. Yes.
Uh, Thank you very much, ma'am. So, those are all the questions. And I would just like to read out this comment by Sudeep. Thank you for this interesting session today. It was fascinating and knowledgeable. So, he has thanked the history enthusiast, but I think thanks also goes to the resource person for making it so interesting and fascinating. So, Nidhi, do you have anything else to say or ask?
Ma'am, I'm just a bit curious that in many movies, as we see, particularly English movies, that these fossils sometimes are shown as they revive it. So, practically, is that possible or not? I think it's not, but
No, no, no.
just want.
What revive meaning they come alive?
Yeah, in fact, in Jurassic Park Part 2 movie, also we see that they revived the fossils. So,
No, no,
practically,
that's
it's
not
not
possible.
possible, right?
Not at all possible. They are
Just
all
definitely.
dead and gone and completely replaced by minerals. So their whole thing of there's no soft parts of that particular animal still there. So these are just fiction which are shown through movies. But I think students should watch such movies because they give you some ideas. And at the same time, please read also. You read some scientific journals if you're interested in finding out things, because in movies it is part fiction, it may not be really true, but whatever they have recreated in Jurassic Park, it is a good way to tell you about how those creatures were and where they were living and things like that. It helps you imagine. That's one thing good, but I would say that try to read many of the scientific geology journals if you're interested. And now everything is available on the net. It has become so easy for students compared to what we had, or even Shastri sir's time. Nothing must have been there. It must have been so tough. We had to go to library and look for books to um, read. So in and one could also start with, looking at, say, the geological history of, say, our own country, in what areas what we are finding. We talk about the Gondwana land and things like that. So you can try and find out, so it is not only when humans came onto the earth and made all the civilizations and everything, but there was something much before that which has been shaping the earth. So one could get interested even in that, and one should not be also thinking about that, okay, I'm not a geologist and I may not be able to comprehend so much, but there are simplistic ways of reading these things and trying to understand. Okay, so one doesn't have to be a very big scholar to appreciate some of these things. And I think National Geographic, Discovery Channel, they give you so much of information in that sense.
Absolutely, ma'am. Uh, Thank you so much. And just another curiosity of mine, is DNA analysis possible for these invertebrate fossils, which are millions of years old?
Not that I've heard of. They have been doing for some of the quaternary fossils, but I'm not so sure about for such very older fossils, because something has to be preserved. So I'm not sure about that.
Thank you very much, ma'am. Before ending the lecture, uh, ma'am, do you have any message for the history enthusiasts, as you just said? But here we are all history students, some with connections with archaeology. So, any message for us why we should enter into the fields of geology and paleontology as well, along with our own studies that we are doing?
See, first of all, I really thank your platform, because you all are, from your own little ways, you all are, spreading this whole this thing idea about archaeology and making people interested in the subject. So it's a very good effort you all are taking. Yes, it is important. See, we cannot be master of everything, but I think a subject like archaeology or history, we cannot just now limit it to only knowing about temples or inscriptions or things like that, but it is much bigger subject. And I also tell my students that it has become a very scientific subject, because we are using a lot of scientific techniques for interpreting the past. It has become more scientific, because the kind of methodologies we are adopting. And here all your geological sciences have, and even natural sciences are playing a very big role, because they are contributing to help you learn about, say, animal domestication, human evolution, understanding of beginnings of agriculture, because they have got certain methodologies which they have developed, or certain techniques which they have developed, which we are using now in archaeology. For example, geology also, you need to understand, say, prehistoric sites, their settings. So a little bit of geological information would be very much required when you are looking at such sites of such antiquity. And so this is where one cannot be very restricted. Today it's a very multidisciplinary subject, so borrow things from social sciences, borrow things from the natural sciences, physical sciences. As much as possible, you can borrow ideas and the kind of research which is being done, and use it in your own work. You will be able to achieve better results, even in interpretations of, say, your temple sculptures and things like that. You would require information from geology to tell you what rock is being used, and why certain sculptures may be doing better than, and some are deteriorating, so in terms of conservation and things like that. So I think archaeology doesn't stand alone, or even history. These disciplines have to be merged somewhere. So one needs to have a little bit knowledge of about everything. We cannot master everything, but at least be familiar with what are the developments in these subjects.
Thank you so much, ma'am.
Okay.
So now we have come to the end of the lecture. Before I inform Nandan sir to propose the vote of thanks, I just wish to announce that uh, from October 14th, we are going to start a new lecture series where we are collaborating with Department of English Literature, Rani Chennamma University, Belagavi, and the theme which we have selected collaboratively is locating Indian history in oral narratives. So till now we have found 20 resource persons. So it will be a long lecture series of 20 days. Uh, so I request audience to also actively participate in this series, and the details will be surely shared in the group. You can check it out. So now I request Nandan Shastri ji to propose the vote of thanks. Over to you, sir.
Invertebrate paleontology is really a very vast subject. And before I propose vote of thanks, let me inform the august audience also that I have taught paleontology at University of California, Berkeley for 10 years through a sphere. I was fortunate to be involved in a project by National Oceanic and Atmospheric Administration. And I am very happy to announce that National Council of Science Museums, Government of India, has now fabricated and patented knowledge on a sphere. The sphere is connected with satellites, and we learn paleontology through this new medium called uh, knowledge on a sphere. Uh, so Arati ji has done full justice and given us a very good glimpse of invertebrate uh, assemblages. And uh, her quality of slides are also very good. Uh, the question and answer session was also very interesting and uh, fruitful. And I thank also uh, Manali and Nidhi working very hard for the preparation for today's event. And uh, I thank also the audience who took active interest to listen to Arti Deshpande-Mukherjee. Uh, Thanks to all. Namaste. Astu.
And
Thank you, sir.
thanks. Yes.
Yeah.
And also thank you to Nandan sir for always being a support for the history enthusiasts and for being part of today's lecture. With this lecture, we conclude the webinar, Paleo Worlds, History, Heritage and Horizons. So this was the last lecture. We had already had the valedictory speech earlier because we had to postpone this lecture, but this is the conclusion. And there is the participants who had registered will be getting your certificates in a couple of days. So please bear with us for that. And thank you all very much for being a part of this beautiful journey of learning and understanding. So thank you all. Thank you. Thank you very much. Thank you, ma'am.
So thank you, sir, and thank you, Nidhi and Manali, for hosting this talk and for the invitation once again. And I wish you all the best with your journey.
Thank you
Thank
so
you.
much, ma'am.
In future
Yes.
also we will look forward for your talk.
Yes, sir. Anytime. I like to talk and I like to teach. So I can you can have
We will
something on the
definitely,
Harappan civilization or you know.
yes, because I come from the Kutch region. My family is from the Kutch region, so I'm very much
Oh,
interested to study the history of that area because I left the I haven't been a part of that culture, but I would love to know more about that. So definitely we will have a talk on it soon
yeah.
whenever
Because
it is
I've done
convenient.
some very interesting work in the Kutch region, and really Kutch region is very close to my heart. Especially Dholavira is something
Yes.
phenomenal. So yeah.
Thank you so much, ma'am. So we are ending the stream here. So this is not goodbye. This is we will see you again soon, and do subscribe to the channel if you haven't already, so that you can get the notifications for any new lectures that we have. So see you all. Have a great weekend, and stay in great spirits. Thank you. Bye bye.
Okay. Bye bye.